In this discussion video, we will do a derivative rules example. So we are talking about section 3.1 here. So first recall that when we write d dx, this looks like a fraction, but it's not actually a fraction, it's just notation. So I don't say d over dx, this is just d dx. This means take the derivative of, and I'm going to write dot, 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 because it means take the derivative of whatever we write after it. Okay, and it means take the derivative of whatever that is, whatever we write after it with respect to x. Okay, so x is our variable here. And so conceptually, if we think about a derivative as an instantaneous rate of change, what taking the derivative with respect to x means is, what is the instantaneous rate of what's the instantaneous rate of change of our function if x changes by a tiny amount? How much will our function change? How much will its outputs change? Okay. So for right now, for our purposes, the variable will always be clear from the context. Once you get into situations, there are situations where you can have a function with many variables in it. And that's the basis of multivariable calculus. And there, we have to be a little bit more careful when we talk about what variable we're taking the derivative with respect to. All right, so let's review some derivative rules. So if I take d dx of c, this means the derivative of c, and I mean c is a constant. Remember, the derivative of a constant is 0. The derivative of x to the n, using the power rule says I'll bring the power down, and then I'll get x to the, and then subtract 1 from the power. So I get n minus 1. So in that formula, n is any real number. So it's not a variable, n is some real number. Like maybe it's x to the 5 or x to the pi, any real number. All right, next rule says if you take the derivative of f of x plus g of x, that's just the derivative of the first function added to the derivative of the second function. So plus d dx of g of x. Similarly, if I take d dx of f of x minus g of x, that is going to be d dx of f of x, and then minus d dx of g of x. And then finally, if you take the derivative of some constant multiplying our function, you can pull the constant in front and multiply that constant by the derivative of that remaining function f of x. All right, so let's do an example. All right, so this is problem number 7a from worksheet 5, and we want to compute the derivative of, I just want to do part A, f of x equals x to the 14 minus 8x to the 4 plus cube root of x plus 6x plus 2 minus 3 over x squared. So I want to first give you 2 minutes to try this on your own. So pause the video for in 4, 3, 2, 1, pause it and try this for 2 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 2 minutes. So what these rules above essentially say is that when we take the derivative of this whole function that has all of these terms, like x to the 14 minus something and then plus something, that we can sort of do the derivative piece by piece. Because if I did the derivative of the x to the 14 minus 8x to the 4, the second to last rule says, well, that's just the derivative of x to the 14, and then I could do that first and then do minus the derivative of the next term, the 8x to the 4. Okay, and similarly, if I wanted to now just do the derivative of 8x to the 4, because 8 is a constant multiplying x to the 4, what this last rule says is, well, just pull the 8 out in front and then do the derivative of x to the 4. Okay, and that'll basically mean, take the derivative of x to the 4, and then once you do, then multiply that by the 8. Okay, so if we use those, the derivative of the x to the 14 using power rule, the 14 comes down, and then I get x to the subtract 1 from the power, and I get 13. Okay, for the next term, remember 8 is a constant, it's multiplying the x to the 4, so the 8 should stay there and multiply the derivative of x to the 4, using power rule, that's going to be 4x to the third, because the power comes down, and I subtract 1 from the power. All right, for the cube root, it's going to be helpful to rewrite this as a power. This is x to the 1/3. And now if I do the power rule, the 1/3 comes down, and I get x to the negative 2/3 when I subtract 1 from the power. Okay, I'm going to go a little bit more quickly now. The derivative of 6x is going to be, I'll have the 6 there, and then x is technically x to the 1. So power rule there will give me 1 comes down, and then x to the 0. Okay, if you knew the derivative of x was just 1, you could have said that as well, because x to the 0 is just going to be 1, so you get 1 times 1, which is 1. Okay, the derivative of 2 is 0, because that's a constant. So I'll get plus 0, and then for the last term, let's rewrite this by bringing the x squared up to the numerator, so I can handle it. So I'll get, let's see, let's put the negative sign with that too, so I'll get minus 3x to the negative 2. So when we do that derivative, I'll have the minus 3 that stays just multiplying it. And then power rule on x to the negative 2 gives me negative 2x to the negative 3. All right, let's do a quick simplification. F prime of x equals 14x to the 13 minus 32x to the third, and then plus a third x to the negative 2/3 plus 6, because x to the 0 is 1. And then minus 3 times a minus 2, that's plus 6, x to the negative 3. And that is my derivative. So as we get more comfortable with these, I won't do steps like, write out the 8 times 4. I will jump straight and bring the 4 down and multiply it with 8 and just go straight to the 32x to the third. Similarly, I'll do stuff like the derivative of 6x just in one step, and I'll just say, oh, that's 6.